Hey there, Certheads. Welcome back to the channel. You're here for the 8th video in our ongoing SAP on Azure series, and this one's packed with value. Today, we are going into the third video of SAP on Azure for networking series, and trust me, you don't want to miss this one. Let's see what's on the menu today. We're diving into what is DDoS and how to protect yourself from DDoS in cloud. We'll be looking into cross-premises connectivity. We'll be looking into the magic of SAP Router. We are talking about SAP Recommendations for networking. We'll also see how to make our Terraform code better. And of course, at the end, I'll be sharing some bonus content, which is Q&A, which will help you prepare better for the exam, which is AZ-120. It's going to be packed with tips, best practices, and pro insights. So stick around till the end. And hey, if you are new to the channel or returning back, welcome to Certheads. Make sure to check out my previous videos to catch up if you want. We are on our journey to ace AZ-120 examinations from Microsoft, focusing on mastering SAP on Azure. And if you are finding the content engaging, then please consider like, subscribe, comment, and share, so that this video can reach out to more people, and it will also help me get motivated and create more such content. Alright, Certheads, let's dive straight into it. Grab your notepads because today's session is loaded with knowledge bombs. Let's start with a big one, which is what exactly is a DDoS attack and how do you protect your SAP workloads on Azure from it. What is DDoS? Imagine that you have a server which is handling normal everyday traffic. A DDoS is a malicious attempt to disrupt the normal flow of traffic to that server or system. Now, if you see, the car goes normally, but when you have a traffic jam in between the server and the users, that's the malicious attempt which disrupts the normal flow of traffic. Now, how does it work? The attackers flood the target system with excessive internet traffic, which overwhelms the server and its surrounding infrastructure. Think of it as a massive unexpected traffic jam on a highway, blocking the regular flow of traffic, making it impossible for legitimate users to reach their destination. Now, Azure provides us protection at 3 critical layers. Now, DDoS infrastructure protection is the first layer. What it does is it provides a protection to all the Azure services on the basic infrastructure level, and this one is automatically enabled. The other one is a DDoS network protection, which is for specific Azure resources within a virtual network. And this one includes advanced features like logging, alerting, and telemetry to monitor and respond to the DDoS attack. Third option is DDoS IP protection. It is a paid model, and the customers are charged based on the number of IP addresses they want to protect. It has a DDoS rapid support as well, which provides quick and expert support in case of any kind of attack. There is an Azure Web Application Firewall as well, which provides an additional web application support, ensuring even more security for sophisticated web-based DDoS attack. So Azure's DDoS protection is a layered protection which ensures your infrastructure, network, and individual IPs are secure from malicious traffic, letting you to focus on the application while Azure handles the heavy lifting on your security. Now, all the components that we have explored so far and will continue to explore in the future come together to form what is known as virtual data center. Now, what is the concept of a virtual data center or a VDC? A VDC is a cloud equivalent of a traditional physical data center. As you can see, there are a lot of components which come together to create your data center. In the physical data center as well, you will have a lot of components like the network cables, the racks, and different networking components which come together to create a data center. Similarly, virtual data center also contains of these components, but in a virtual form. Unlike physical data center in which you can walk in and access the hardware, VDC is entirely virtual and can only be accessed via cloud. It combines all the key features like networking, storage, compute, power, security, and management tools into one cohesive environment, all within Azure. Some of the key features of virtual data center are: it's fully virtual, yes, completely virtual, accessible from anywhere around the world. It's highly scalable. You can expand your resources or shrink your resources as and when you want. It is secure and flexible with advanced security like DDoS protection, which we just discussed, virtual networks and firewalls, which ensures you have a seamless protection. In essence, think as virtual data center as a powerful data center in the cloud where all your SAP workloads, networking configurations, and infrastructure come together to operate efficiently without needing physical server or hardware. Pretty cool, right? As we saw the concept of virtual data center, now let us understand cross-premises connectivity. What is cross-premises connectivity? Now there is a virtual data center which is in Azure, and we have another data center which is on premises, which is a physical data center. Now in order to establish connectivity between these two, we need to provide some elements of Azure. We have already discussed about these elements in our previous videos. Now what we are going to discuss now is what is cross-premises connectivity and what is cloud-only connectivity. Now cross-premises connectivity is a setup in which one or more SAP workloads are hosted on Azure IaaS and are fully integrated with the existing on-premises SAP environment. Now this allows seamless communication and data exchange between cloud and on-premises system, and this is also called as a hybrid cloud. Now there is another option which is cloud only, wherein all of your SAP environment is on Azure IaaS with a minimal or no reliance on the on-premises data center. Now, when do you go for cross-premises deployment, and what are the considerations which you should keep in mind when you are going for a cross-premises deployment? In a cross-premises deployment, SAP systems must be entirely located either on-premises or on Azure. You cannot split SAP layers between two. For example, you cannot have SAP applications like database on-premises and application in Azure. That will not work. Also, splitting up of SAP components between on-premises and Azure is not allowed. And distributing virtual machines running SAP instances of a single system across multiple Azure regions is also not allowed. Now, these safeguards have been put in by SAP in order to ensure minimal latency. Latency is real killer in SAP. SAP doesn't like latency because there is a lot of data which is normally exchanged between the SAP systems, so latency is not good. These safeguards ensure a performance and integrity of highly integrated SAP systems. Let us see a few examples of highly integrated SAP systems. Now, one example of highly integrated SAP system is SAP BW, which is reading data from SAP OLTP like ERP or CRM. As you can see a diagram on the screen which shows the flow of data. Now, what is SAP BW? SAP BW is an advanced reporting, analysis and interpretation tool for business data. And SAP BW provides high performance infra and helps evaluate and interpret data. So this is a process which is shown on the screen, which shows the operations of SAP BW. Now, this is a highly integrated system, and this system requires minimal or low latency. There's another example which we will look into. So another example of a highly integrated SAP system is SAP SLT. SLT used to replicate data between multiple SAP systems or between SAP and non-SAP systems. SAP SLT stands for SAP Landscape Transformation Server. It is a component of SAP Business Technology Platform which allows users to replicate data from SAP and third-party systems to SAP HANA in real time. Now, there are various features in SAP SLT like trigger-based change capture, integration, and data transformation before loading onto the HANA database. As we can see, SLT can be configured both for real-time and scheduled data transfer, and it supports multiple system connections. Now, this type of integrations require a close proximity between systems to avoid latency issues, and these ensure high performance across environments. Now let's look into the deployment options for SAP on Azure. So basically we will be looking into two deployment options. The first being a simple deployment. So in a simple deployment, there's a connection between on-premises environment and Azure via a VPN or an express route. And the key characteristics of this kind of deployment is there is a single virtual network in Azure, and the VNet might have multiple subnets. One of the subnets will contain the SAP application, the connectivity, and the DBMS. Now, as you can imagine, the simple deployment like the one we saw earlier will not support large environments. For large deployments, we will use a multiple VNet structure where we have multiple VNets and the same on-premises environment connected via VPN or an express route. So in a large deployment, the key characteristics would be there will be a separate VNets to segment the workloads, and this will ensure scalability. We'll have multiple peered VNets, as you can see in the diagram, and the VNet peering will be used to link different virtual networks, allowing communication between them while maintaining isolation and improving security. The scalable architecture ensures that your SAP environment can grow and remain efficient and be well organized as your needs expand. So when we are deploying SAP across environments or cross premises, we need to ensure that certain traffic is enabled and is accessible across the premises. Now, what are those traffic? Those traffic are basically SAP specific traffic. The first traffic is SAP GUI or RFC traffic. Now, what is this? This is a SAP GUI, graphical user interface for SAP, and RFC stands for remote function call traffic. This traffic must flow seamlessly between on-premises and SAP instances which are hosted on Azure. The next traffic would be SAP transports traffic. The transports traffic is basically the transport management system which supports SAP transports like changes and updates across the landscapes between on-premises and Azure hosted instances without any latency issues. The next traffic is SAP Solman or Solution Manager traffic. Now, SAP Solution Manager traffic or OSS, online services traffic, connectivity between on-premises and Azure ensures that the system health checks and monitoring support operations work seamlessly. The next traffic considered should be the SAP systems interface traffic. This ensures smooth communication between SAP systems and any kind of external interfaces like third-party software or any non-SAP systems through a hybrid environment. We should also consider printing, backup, and monitoring services. These ensure that printing services, data backups, and system monitoring are properly integrated across hybrid landscape with both on-premises and Azure systems covered. On-premises network printers should be accessible to Azure-hosted SAP instances through a VPN or an express route. Monitoring tools like Azure Monitor should provide visibility to both on-premises and cloud environments for effective oversight. Now, by facilitating these kind of key elements, cross-premises connectivity ensures that SAP environment functions as a unified system and regardless of where the components are located. Now, there are instances wherein your SAP environment would need support from your SAP vendor, and they would need to log into your SAP systems and perform troubleshooting. And in order to do that, you should provide something called as SAP Router. Now let's discuss about SAP Router. The SAP Router is a tool for allowing remote access to SAP systems. So basically, SAP vendor logs into your systems and performs any kind of troubleshooting. There are two deployment scenarios. One deployment scenario is where your SAP system is running in Azure with an on-premises environment. So this is kind of a hybrid deployment. So if you have an existing on-premises SAP environment, you likely have an SAP router in place. Now what you would do is you extend this setup to your SAP environment hosted in Azure. You maintain a private and a static IP addresses of the virtual machines in Azure that host SAP configurations, and you configure NSG for the subnet hosting virtual machines to allow traffic on TCP IP port 3299. That is where SAP router would communicate, and you would allow traffic on port 3299, a TCP IP traffic, which will be used for SAP router for communication. The next setup would be an Azure only deployment where you do not have any on-premises SAP router. In this case, you would deploy a VM in Azure and you would assign a static IP address to that VM and allow TCP port 3299 to communicate through the SAP support. There are some key points which we need to remember. Port 3299 should be enabled and it should be opened in NSG to enable traffic to the SAP router. Static IP addresses to ensure consistent connectivity between SAP systems and SAP router. An SAP router is very critical for remote troubleshooting and SAP support access in both hybrid and cloud environments. Next, let's look into some of the recommendations from SAP for networking. They are broadly categorized into three sections. The first section is network security, network performance, and network reliability. Now, what are those? Let us discuss in detail. Now, network security, SAP recommends for hybrid environment to use site-to-site or express route only to the applications hosted in Azure VMs. End user access should be routed via company's intranet. Hence, all on-prem security policies are retained and extended to Azure as well. SAP applications and DBMS layer should be segregated using only subnets. So you should not place them in different VNets, rather use subnets. VNet segregation can be considered. However, you should also think that there is an additional cost of data transfer when you segregate SAP applications and database into different VNets. Now, on network performance, SAP applications and DBMS layers should not be segregated between on-prem and Azure. This might lead to a high latency. Choose Azure data center close to your on-premises location for the least latency. And we should not place any NVAs like firewalls between SAP application and DBMS layer. This will again increase the latency. The third pillar is network reliability. Use good quality low latency connection between the data center and Azure. Again, consider express route. And verify and monitor the bandwidth so that it is optimal to handle the data transfer and load. In case you figure out that there is an extended load, an extra load, then you should consider upgrading your express route as well. Alright folks, let's come back to our Terraform code now. What we have done with our Terraform code is we have created a resource group, we have created a VNet, and we have created subnets under that VNet using Terraform code. Now what are we going to do next? We are going to make our code look better. Now how do we do that? We are going to introduce something known as variables in this section. Now why do you want to introduce a variable? Now variables make your code more flexible. It will help you store and organize the data. It will also make the program easier to understand and will simplify the code maintenance as well. Now let us understand how to variabilize the code. Now we will not want to use any of the values which are here on the main, which is like location UK South and the name in the main.tf. Instead, we will pass variables here and then we are going to give values to these variables. How do we do that? First things first, you need to add a file called variables.tf, and then you need to write variables and the name of the variable, say location, and a description. We will say the location of the resource. You can give any description, doesn't matter. A default value, I'll give it a location value UK South. This is the default value of the variable. If you don't pass this value, Terraform will ask you for this value. As of now, we will pass the default value in the variables file. Pretty good. Now let us go ahead and change the value of location. We will say var and the name of the variable. The Terraform is automatically identified that there is a variable file, and it has also read that there is a variable called location there. So what I have done is I have removed the actual value from the main and I have put the value in the variables file. Now this looks like something like this. What I am going to do is I'm going to change all these values into variables and come back. Okay, so now I have updated the variable file with all the variables. All the values which we had on the main.tf are now variabilized. As you can see on the main.tf, I have added var dot the name of the subnet, the address space. Now let us perform a format. Now this is going to format all the files and make sure that everything is aligned and it looks good. Now we are going to do a Terraform init to make sure all the configuration looks good. It is successful. Let us perform a Terraform plan to see what Terraform is going to apply on the configuration. Is it consistent with the code which we have created? And we can see it says plan 6 to add, 0 to change, 0 to destroy, and it has taken into account that it needs to create a resource group, subnets and vnet. Let us go ahead and apply it with an auto approve flag so that it does not ask for an approval. We can go and check on the portal. As of now, the resource group is not there. It should come up shortly. So Terraform is applying the resource group, is creating the vnets and the subnet. Let us refresh. That's great. So now we have our code variabilized. I'm going to push this into Git. All right, so as promised, let's look into some of the bonus content, which is question and answers. First question is, you are deploying SAP on Azure. The database server will use SAP HANA and the application server will run on Windows Server. You need to test the latency and throughput between the front-end server and the back-end database server. Which three tools can you use to achieve your goal? HCMT, SOCPerf, Latte, IOmeter, and NIPing. The answer is NIPing. It's a tool provided by SAP. IOmeter, it's a tool commonly used for benchmarking and testing performance of storage systems. And SOCPerf, it's not a standard tool, but it's possible that it could be used in a custom or an industry-specific environment. The next question, you plan to migrate your landscape to Azure. You need to configure your VNet to support the SAP landscape. To configure site-to-site VPN, you must do any of one of the following: add gateway subnet, add a virtual network gateway, or increase the address space. To allow peering to route traffic via VNet, you must do any one of the following: enable forwarded traffic, enable gateway transit, or use remote gateway. The answer is you should add a virtual gateway subnet, and the second option, to allow peering, you must use remote gateways. The next question, you are planning a small scale deployment of SAP HANA on Azure large instance landscape. You identify the cost of virtual machine SKU required to host HANA large landscapes, with which additional cost would be incurred: an Azure Rapid Response Support contract, an express route circuit between HANA large landscape and the Azure, a Linux support contract, or a site-to-site VPN connection between HANA Large Instance TAMP and Azure? The answer is Express Route Circuit, because in HANA Large Instance TAMP, you would normally use an express route because there's a lot of data which is flowing in between on-premises or Azure landscape and HANA Large Instances. Alright folks, that brings us to the end of this topic, and it also brings us to the end of SAP on Azure Networking series. Next, we will pick up another topic and another module. Thanks so much for watching till now, and I'll see you in the next one.